Hi there, and welcome to Scientific Adventures of Beardman. Today we're going to take a look at Newton's second law. Newton's second law talks about what causes objects to change their velocity. Remember, in Newton's first law we saw that an object will maintain a constant velocity if there is no net external force on the object. Well, now in Newton's second law, we're going to look and see what happens if we do put a net external force on an object. Once again, we're going to talk about the net and external later, so right now we're just going to say if we put a force on an object. Well, Newton's second law says that an object will accelerate when there's a force put on it. And the amount of acceleration is directly proportional to the amount of force. Okay, that's half of Newton's second law. And so if we take a force and we push on an object, if we push twice as hard, the object will change velocity twice as fast, meaning it has twice the acceleration. So if we push twice as hard an object, the object will accelerate twice as fast. Or if we put 5 times as much force, it'll accelerate 5 times as fast. They're directly proportional. Same thing, of course, goes if we decrease the force. If the force gets much weaker, the acceleration will be much smaller. Okay, that makes sense. You've put a big force on something and seen it change velocity quickly, and put a small force on something and seen it change velocity very slowly. Okay, for any sport will give you this example. If you put a little bit of force on a baseball, we call it a bunt. Then the ball doesn't change velocity very much or very quickly, and it doesn't go very far. Okay, if you put a big swing with the baseball bat, then it'll put and you put a big force on the ball. Well, there'll be a big acceleration causing a big change in velocity, and the ball has enough velocity it can zoom over the fence. The other half of Newton's second law deals with the mass of the object. And it says the mass of an object and its acceleration are inversely proportional. Okay, so if I were to go and push an NFL player, assuming they're big, which most of them are, okay, I push one of them. Well, they got a big mass, and they're not going to accelerate too much. That's kind of the idea in football. When you push on somebody, you don't want them to accelerate much because they want to pick their own acceleration, so to speak. Okay, but if I, were crazy and went down to the local kindergarten and pushed a kindergartner, well, they would change velocity very quickly. They would accelerate very quickly. Don't worry, I'm not crazy. I don't push kindergartners. But you get the idea. You can picture pushing an NFL player next to pushing a kindergartner, and you can see easily how the acceleration of the two would be different. The bigger the mass of the object, the smaller its acceleration. If it has a small mass, it has a much bigger acceleration. Well, now we can put these two proportionalities together. The fact that the force and the acceleration are directly proportional, and the fact that the mass and the acceleration are inversely proportional. And if we put those together in an equation, we get this equation that the acceleration equals the force divided by the mass. Most of the time we see this equation rearranged with the mass on the other side, and we get how most people say it is F equals ma. Of course, we will say force equals mass times acceleration. And this, one last time, this describes for us how an object changes velocity, that it's caused by a force. Don't forget that force will be measured in newtons, and a newton is a kilogram meter per second squared. Acceleration, as we've already learned, is measured in meters per second squared, and mass will be measured in kilograms. And you can see when we do kilograms times meters per second squared, we get a kilogram meter per second squared, which is also in Newton. Thank you for watching. I hope you've enjoyed Newton's second law. Check us out next time on Scientific Adventures of Beardman.